Hello, today in this video we're gonna discuss about regression model with multiple levels of categorical variables. For that, let's look into this example. The surface finish dataset provides measurements of the surface finish of 35 parts produced on a lathe, along with the revolutions per minute, right here, of the spindle and one of the four types of cutting tools used, that is A, B, C, or D. The engineer who collected the data is interested in predicting surface finish as a function of RPM and the type of tool. So we can say that surface finish is the dependent variable here, and RPM and the cutting tool are the independent variables. Generally, as we have seen in the previous examples, we should code the categorical variable as 0 and 1 and run the regression analysis. But here we have four categorical variables. So if we run all the four categorical variables and code them to run the regression analysis, it would create a number instability in Excel which would crash the regression analysis tool. Therefore, we're going to create 4 minus 1, that is k equals to n minus 1 equals to 3 categorical variables to run in our Excel analysis tool pack. So let's create 3 new columns with categorical variable tool B, tool C, and tool D. So we're going to code them. If the machine is using tool B, it would be 1, or else it would be 0. So you can use the formula equals if cutting tool equals B, then we can use the code 1 or else 0. So hit enter and then double click the small square to fill out the rest of the column. Similarly with tool C and tool D. After this, we're going to run the regression analysis using the RPM and the 3 columns. But to run the regression analysis, you need to have all the independent variables in the adjacent columns. So we're going to move the cutting tool column to the end of the line. And then we're going to remove this column. Now we can run the regression analysis without any problem. For that, go to Data, Data Analysis, click on Regression. The Y range is the dependent variable, that is the surface finish, and the X range are the independent variables, that are RPM, tool B, C, and D. Make sure you check the labels box, and then we can create the output right here. Then hit OK. So this is the output that you would get from regression analysis tool, even if you have multiple categorical variables. So here, looking at the p-values, we can see that RPM, tool B, C, and D all are significant indicators of surface finish, since all of these have p-value of less than 0.05. So all are significant indicators of surface finish. Likewise, significance f is also less than 0.05. Therefore, we can conclude that our model is statistically significant in explaining the variation in surface finish. Looking at R square, we can say that approximately 98.89% of the variation in surface fitness is explained by RPM tool B, C, and D. The remaining variation is due to other factors that were not included in this model.